Saxon's Calculus Lesson 68 is about computing areas. So in example 1, it says find the area between the graph of y equals sine of x, which I sort of listed here, and it's bounded on the x-axis between 0 and 2 pi. So I went ahead and did the sketch. That's your normal sine curve. So you're talking about the area here and here. And so we know that to do that, we're going to integrate the sine of x between 0 and 2 pi. And when we do that, sine goes to negative cosine. However, we remember that it shifts to the closest cosine start. So that changes our boundaries to 0 and pi, because the closest one would be here. So 0 and pi. So then on the calculator, rather than graphing them, you're going to do cosine of 0 and negate, cosine of pi and negate that answer. And then minus the cosine of 0 and negate that answer and put them together. And you should get 4 units when you do that on your calculator. So it's just a matter of practicing that on the calculator so you figure out how you get to 4 units. Now, example 2. Find the area of the region bounded by the graph of y equals x squared minus 1. So we know we're going to be integrating x squared minus 1. And the x-axis between negative 2 and 2. Okay. All right. Now, I do have to remember that part of this graph, and they go ahead and show you the graph there on page 340, because it's a parabola, part of it is in the positives and part of it is in the negatives. So you see in their answer that they're splitting this basic one that I did, not from negative 2 to 2, because part of those are positives and part are negatives. So they actually graph it and then use those as the boundaries to determine that it's positive between negative 2 and negative 1. Then it is negative between the negative 1 and the 1, and then positive again between 1 and 2. And so they do each of those separately. They still get the answer of 4 units. Hang on a moment. Yeah, I wanted to double check it. I was fairly certain that yes, you absolutely have to figure out which are in your positives and which are in your negatives. If I just go from negative 2 to 2, what I discovered is that I have a 2/3 and a negative 2/3, and they basically undo themselves. So that's not helpful. So we are going to do the integration from our negative 2 to negative 1 for, okay, so this part I can keep because it was my, this one I could keep. It was my negative 2. So that answer came out to be negative 2/3. Okay, negative 2/3. And then, because it's in the negative section, I should be making that positive. And then the other one that was negative went from, oh goodness, those are my positives. Hang on. 1 to 2. Let me just go ahead and do that one. 1 to 2. 2's answer I already had at 2/3. Okay, so 1's answer would be 1/3 minus 1. So that would be negative 2. Ooh, is that killing each other off? Between 1 and 2. That's very possible. Okay, so maybe my answer here is actually 0. And then I need the negative 1, which was the integration from the negative 1 to 1. I don't think I ever did that one. So 1 being the highest one would be 1/3. Oh yeah, I did right there. Negative 2/3 minus the lower answer, which would be negative 1 cubed. So negative 1/3 plus 1. So that would be 2/3. That's negative 4/3 when I put that together then. With, I'm wondering if I dorked a sign here, because negative 4/3 and negative 2/3 combining together would be negative 6/3. That's only 2. Let me find my error. Okay, I finagled and finagled the numbers and was double checking everything. My problem is in the fact that when I did these numbers, this one I incorrectly had a 0, so I just redid the fractions, but this one is coming out negative 4/3 and this one is coming out 4/3. However, they are both in the positive section, so it should be positive for them because they are in the positives. So then in the negative section, this was supposed to be negative. However, I'm adding all of their areas together. So there is your 4, 8, 12/3, ignoring the signs on all of them basically. 12/3 divided then is the 4 units squared. All right, let's try example 3, I guess that is. Find the area of the region completely enclosed by the graph of y equals negative x cubed minus x squared plus 2x and the only other boundary it gives me is the x-axis. So we need to figure out the different sections that we would have by graphing this. By all the methods that we have used thus far. So they pull out a negative x, leaving a positive x squared plus x minus 2. And then they factor to negative x, x and x, 2 and 1. 2 is bigger. It should have the positive from the middle. How do I go from 2 to 1? I'm minus 1, and negative times positive is negative. That's correct. So then I would have dots at 0, 1, and negative 2. 0, 1, negative 2. And then I would need to, well, again, using all methods I know, I can have up to 2 curves because the highest exponent is 3. It's negative, so overall it needs to be going down. So that being the case, I know I'm heading down here. At some point I've got to swoop and get back up to here, and then I've got to bounce to here somewhere and then finish going downward. So there is the rough sketch of. So I see that if I'm bounded by the x-axis, I'm going to have between negative 2 and 0, and then between 0 and 1. So we need to integrate from, the lower one was negative 2, the higher one was 0, and our equation, I'm just going to go ahead and write beside it what that is. So that's going to be negative 1/4 x to the 4th minus 1/3 x cubed plus, and 1 plus 1 is 2, dividing, that's going to lose that and go to x squared. Okay, make sure I have no errors in there. Yes. Okay, and then we need to do the same thing, except our second boundary is going to be from 0 to 1, but the same equation. All right, so I realize I'm not using correct math format here. I'm just trying to get the problem solved. So technically this is already the integration part, so this symbol isn't there. It should be with the line and the 0 and the negative 2, and the same thing here. I just was kind of jotting it notes to help me get through. So then I'm going to plug in the 0. Well, that's going to give me 0 for that whole thing. And then we're going to minus from that the answer from -2. So that's going to be 4, 8, 6. So positive 16 divided by the 4 is 4. So that's -4, -8. So positive 8/3. Double check that. -8. Yes. Okay. Plus 4. -2 squared is 4. Common denominator makes 12. 12. Oh, I guess I could have seen those killed themselves off, leaving me the 8/3, which I should be minusing because I was hoping. Yeah, it is. Okay. So then that's the answer from this first one. And we need to combine it with the answer from this one. So our highest one is 1. When we plug that in, that's going to give us -1/4 minus 1/3 plus 1. Common denominator is 12, 3, 4, 12, and 12. I was going to say, well, where's the other half of that number? So -3 and -4, -7. So 5/12 is the answer to the highest one minus the 0. Well, the 0 doesn't have anything. So then, since I don't care about the signs, this is 8/3 plus 5/12. Common denominator 12, 4, 32, so 37/12 units. Yes, units squared, because they didn't give me any label.